My name is Krunal Chawda, and this is my presentation for PRISM. And I'm an AI research assistant here at University of Saskatchewan. So I built this system alongside with Devin and Dean. So first of all, I would like to show you the live map. It basically shows you all the bridges and all of that stuff here in British Columbia, which are like the conditions and all of that stuff. And then again, I can just click here and show me critical bridges in BC, and it goes on and shows me all the critical bridges that are there in BC. So we can use natural language to query all this large databases and make sense from them. Then I have a live government data dashboard. So for example, let's switch to Quebec, and it shows me again basically all the things like all the basically infrastructure from Quebec, critical conditions, replacement value, priority investment needed. Then I have a highway forecaster, which is again, it just has the data of Ontario right now. So I can just do highway, let's do 401 or 401C, whatever you want. There are 0 critical conditions right now on highway 401C. As you can see, these are all the road segments that are there on highway 401C. These are like basic ID creation timeline. It's again, this is the forecaster of like how many segments will turn into critical segments in the next upcoming 10 years. And then I can also run a forecaster here as well, which in real time shows you what is going to happen. And how it is going to affect. So again, it's backed by this. This is the economic impact, what is costing us right now in terms of fuel wastage, rate delays, and all of that stuff. And then again, section impact. So it basically does section impact for each section. This is winter resiliency, which we added by the virtue of being in Canada. Winters are very bad. So these are all the severe sections and all of that stuff that we have added, like pre-winter intervention, ROI, and all of. So if we do intervention before winter, what is going to cost and what is going to cost us after the winter. And then again, this is corridor optimization. So if we bundle 2 corridors together rather than doing them individually, it gives us that. And then I can just go in and show you like the live examples of some of it. So yeah, as you can see, these are all the bundled corridors, and this tells you like what highway direction it should be in and all of that stuff. So yeah, this is another tool that we have built in. And then this is funding optimizer. So let's say I have a $50 million budget and I want to prioritize this thing. So it basically is doing is running risk to cost ratio algorithm on the back end, which does a bunch of math and tells us which are the bridges in critical conditions and like highways in critical condition and what the investment could do to them. I can also go in and toggle like all the other like medium risk, but these are just mostly high risk. And then condition risks, length, estimated cost, what would be cost in their RCR. And then again, this is AI versus traditional. This is still in BERT, so that's why it's 727%, but eventually it'll get better. And then this is all the critical infrastructure greater than 70 risk score that they have. And we have built in, like we have calculated risk scores on various metrics, and some of it is directly coming from infrastructure data from Statistics Canada. So as you can see here, there are multiple, and I can just download the CSV and it would get downloaded, and then I can do like present it to anyone, whoever wants it. And then the last one, and not the least, is our AI agent. So what it does is it's basically it has its own MCP server, which is running on backend. Due to like short duration of this video, I cannot explain MCP in detail, but you can read my GitHub repo for it. So what it does is it's basically going on and querying all the poor condition database. Like it has a bunch of MCP tools, and then it tells me like all the poor conditions bridges in Ontario. Then I can say once it comes back, as you can see, right? Like it's using natural query, natural language. And then I can say, can you tell me the latest updated data sets? So it basically like solves a lot of problems for people who interact with data and who have hard time finding data and all of that stuff. So again, that is one of our solutions to that problem. But yeah, this was an overall rundown of PRISM, and I hope you consider application. Thank you so much.